For our setup, we tied a tennis ball to a string using an eye hook and dangled it above the base of a ramp. This will be referred to as ball A. We pulled the tennis ball up the ramp to its highest possible point where the string is at its max length and the tennis ball is still touching the ramp. Another ball is placed on the ground at the base of the ramp. This will be referred to as ball B. Then we will release ball A, which hauls down the ramp, colliding with ball B. We will repeat this twice for two different masses of ball B. One will be lighter and one will be heavier. Our purpose was to use the conservation of energy to solve for the hypothetical velocity after impact of a swaying ball after it collides with a stationary ball on the ground. We initially wanted to perform a different variation of this experiment, with the hanging ball being stationary and the other ball colliding with it. However, after a few trials, we felt that our setup wasn't allowing for consistent results. Other constraints included difficulty measuring final height, reached by ball 1, and difficulty measuring final velocity, reached by ball 2. Assumptions included 1. We neglected friction. 2. We neglected air resistance. 3. The initial height of hanging ball was always 1.5 feet. And 4. The balls collided perfectly head-on and not obliquely. Because both balls are stationary to begin, neither will have any kinetic energy, and because ball B is on the ground, it will have no potential energy at any point. Sources of error include 1. The effect of string on ball A was not considered. 2. The heavier ball's weight was not perfectly distributed, so rolling may have been altered. 3. Knowing a coefficient of restitution may have helped reduce error. And 4. Camera equipment was not as precise as we would have liked. In conclusion, although we feel that our calculated values for final velocity of ball A in both sets of trials were a little higher than what we expected, the decrease in final velocity of the swinging ball from the light ball to the heavy ball does reflect what we aimed to show when we began our experiment. Because the heavier ball has a greater mass, it will require more force for the swinging ball to move, thus decreasing the velocity with which the swinging ball moves after the collision. If we did this again, we would remove the string altogether and try to more evenly distribute the weight inside the heavier tennis ball.